Good day everyone and welcome to our next lesson, which is Laws of Exponent and its application. Our most essential learning competencies are: the learner derives the laws of exponent, multiplies and divides polynomials. Let's begin our discussion. In the process of multiplication and division of polynomials, you need to apply the laws of exponent. Remember that exponent tells how many times the base will be multiplied by itself. Any number a raised to n, a is the base and n is the exponent. For example, 5 cubed means 5 times 5 times 5, which is equal to 125. In x times x times x times x, the variable x is multiplied by itself 5 times, hence you can write it as x raised to 5. Here, the base is x and the exponent is 5. Exponents have its own rule in performing mathematical operations. So let's have the laws of exponent. The first law that we have is product law of exponent. Any numbers m in integers x and y, so we have m raised to x times m raised to y is equal to m raised to x plus y. The base must be the same before you can add the exponents. For example, b squared times b cubed is equal to b times b times b times b times b, which is equal to b raised to 5. Similarly, we have b squared times b cubed is equal to b raised to 2 plus 3 is equal to b raised to 5. The second law is Quotient Law of Exponents. Any number in integers x and y, so let's have letter A, m raised to x over m raised to y is equal to m raised to x minus y if x is greater than y. Next is m raised to x over m raised to y is equal to m raised to x minus y is equal to 1 if x is equal to y. And m raised to x over m raised to y is equal to m raised to x minus y, which is equal to 1 over m raised to x minus y if x is less than y. For example, letter A raised to 5 over a raised to 2. So we have a times a times a times a times a over a times a. So we're going to cancel the 2 a's. So the remaining a is a times a times a, which is equal to a cubed. Similarly, a raised to 5 over a raised to 2 is equal to a raised to 5 minus 2, which is equal to a raised to 3. Next example, we have a cubed over a cubed is equal to a times a times a over a times a times a, which is equal to 1. Similarly, a cubed over a cubed is equal to a raised to 3 minus 3 is equal to a raised to 0, which is equal to 1. Note, any number raised to 0 is always equal to 1. Another example, a squared over a raised to 4 is equal to a times a over a times a times a times a, which is equal to 1 over a squared. Similarly, a squared over a raised to 4 is equal to 1 over a raised to 2 minus 4, which is equal to 1 over a squared. Third law, power of a power rule. Any number m in integers x and y must be m raised to x raised to y is equal to m raised to x times y. For example, a squared cube is equal to a squared times a squared times a squared, which is equal to a raised to 2 plus 2 plus 2, which is equal to a raised to 6. Or a squared cube is equal to a raised to 2 times 3 is equal to a times 6. Another example, a squared over b cubed raised to 2 is equal to a raised to 2 times 2 over b raised to 3 times 2 is equal to a 2 times 2 is equal to 4. Therefore, we have a raised to 4 over b raised to 3 times 2 is equal to b raised to 6. The next law is power of a product. Any numbers m and n, integers x. mn raised to x is equal to m raised to x n raised to x. For example, 2ab raised to 3 is equal to 2 raised to 3, a raised to 3, and b raised to 3 is equal to 2 raised to 3 is equal to 8, and a raised to 3 is equal to a cubed, and b raised to 3 is equal to b cubed. Therefore, our answer is 8a cubed b cubed. Next law is power of a quotient. Any numbers m and n, integers x. So we have m over n raised to x is equal to m raised to x over n raised to x. For example, 3 over 2 raised to 3 is equal to 3 cubed over 2 cubed, which is equal to 3 cubed is equal to 27, and 2 cubed is equal to 8. Therefore, the answer is 27 over 8. We can apply the laws of exponents in multiplying or dividing polynomials. So now, let's have the multiplication and division of polynomials. For example, multiply 3xy and 4xz. So our solution, 3xy times 4xz is equal to 3 times 4 times x times y times z, which is equal to 3 times 4 is equal to 12, then x times x is equal to x squared, and we're going to copy the variable y and variable z. Therefore, we have 12x squared y z. So, the first thing to do is to multiply the numerical coefficients, then add only the exponents of the same variable and copy the rest of the variables. Another example, find the product of 3abc and 4a squared plus 3a minus 5. Our solution, we're going to use the distributive property. So we have 3abc times 4a squared plus 3a minus 5 is equal to 3abc times 4a squared plus 3abc times 3a plus 3abc times negative 5. As you can see, we distributed 3abc to 4a squared plus 3a minus 5, which is equal to 3abc times 4a squared is equal to 12a cubed bc plus 3abc times 3a is equal to 9a squared bc plus 3abc times negative 5 is equal to negative 15abc. Another example, what is the product of m minus 4 and m squared plus 3m plus 7? So our solution, we're going to use the distributive method or horizontal method. So we have m minus 4 times m squared plus 3m plus 7. So we have m times m squared plus 3m plus 7 minus 4 times m squared plus 3m plus 7. So we have m times m squared is equal to m cubed. M times positive 3m is equal to positive 3m squared. Then m times 7 is equal to positive 7m. Then negative 4 times m squared is equal to negative 4m squared. Then negative 4 times positive 3m is equal to negative 12m. Then negative 4 times positive 7 is equal to negative 28. So we're going to combine like terms or similar variables. So we have m cubed plus 3m squared minus 4m squared. As you can see, they have the same variable and exponent. Plus 7m minus 12m minus 28. Then, we're going to perform the operation. So we have m cubed plus 3m squared minus 4m squared is equal to negative m squared. Plus 7m minus 12m is equal to negative 5m. Then, copy negative 28. Therefore, the answer is m cubed minus m squared minus 5m minus 28. On vertical form, we have m squared plus 3m plus 7 times m minus 4. So we have m times m squared is equal to m cubed. M times 3m is equal to positive 3m squared. Then m times 7 is equal to positive 7m. Then on negative 4 times m squared is equal to negative 4m squared. The negative 4 times positive 3m is equal to negative 12m. Then negative 4 times positive 7 is equal to negative 28. Adding the answer, we have m cubed. We're going to bring it down. So we have m cubed. Then positive 3m squared plus negative 4m squared is equal to negative m squared. Then positive 7m plus negative 12m is equal to negative 5m. Then we're going to bring down negative 28. Therefore, the answer is m cubed minus m squared minus 5m minus 28. Another example, find the quotient of 25x raised to 5 y squared z cubed divided by 5xy cubed z squared. So for our solution, so we're going to divide 25x raised to 5 y squared z cubed divided by 5xy cubed z squared. So we're going to divide the numerical coefficients, then apply the quotient law of exponents. So we have 25 divided by 5 is equal to 5. Then we have x raised to 5 and x. So we're going to have x raised to 5 minus 1. Then we have z cubed minus 2 over y cubed minus 2, which is equal to 5x raised to 5 minus 1 is equal to 5x raised to 4. Then z, 3 minus 2 is equal to z over y cubed minus 2 is equal to y. Therefore, our answer is 5x raised to 4 z over y. Next example, what is the quotient of 4x raised to 8 plus 6x raised to 6 minus 2x raised to 4 minus 10x squared over 2x squared? So we have 4x raised to 8 plus 6x raised to 6 minus 2x raised to 4 minus 10x squared over 2x squared is equal to 4x raised to 8 over 2x squared plus 6x raised to 6 over 2x squared minus 2x raised to 4 over 2x squared minus 10x squared over 2x squared. So we have 4x raised to 8 divided by 2x squared is equal to 2x raised to 6. Then we have 6x raised to 6 divided by 2x squared is equal to positive 3x raised to 4. Then we have negative 2x raised to 4 divided by 2x squared is equal to negative x squared. Then we have negative 10x squared divided by 2x squared is equal to negative 5. Therefore, our answer is 2x raised to 6 plus 3x raised to 4 minus x squared minus 5. So in dividing polynomial by another polynomial, you have to apply the following steps. The first one is arrange both dividend and divisor in descending or ascending powers of common variables, leaving a space or replacing the missing term with 0. The second step, divide the first term of the dividend with the first term of the divisor to get the first term of the quotient. The third step, multiply the entire divisor by term of the quotient and write the product under the dividend of similar terms. The fourth one, subtract similar terms. Apply rules in subtracting polynomials. Then bring down unused terms of the dividend. Then divide the first term of the difference by the first term of the divisor to get the second term of the quotient. Then repeat steps 3 to 6 until the result of subtraction is less 0. Subtraction is 0 or the degree of the term of the difference is less than the degree of the divisor. Let's have the example. Divide 15n squared minus 2n minus 24 by 3n minus 4. So our solution. So the first one is divide 15n squared by 3n. The quotient is 5n. Then multiply 3n minus 4 by the quotient 5n. So the answer is 15n squared minus 20n because 5n times 3n is equal to 15n squared. And 5n times negative 4 is equal to negative 20n. So we're going to subtract the product from the dividend, then bring down negative 24. So we have 15n squared minus 15n squared is equal to 0. Then negative 2n minus negative 20n is equal to positive 18n. Then we're going to bring down negative 24. Then we're going to divide 18n by 3n. So the quotient is 6. Then we're going to multiply 3n minus 4 by the second quotient, which is 6. Then we're going to subtract. So we have 6 times 3n is equal to 18n. Then 6 times negative 4 is equal to negative 24. Then we're going to subtract that. 18n minus 24 minus 18n minus 24. So the difference is 0. Therefore, the quotient is 5n plus 6. To check if the answer is correct, multiply the divisor and the quotient to get the dividend. So our dividend is 15n squared minus 2n minus 24, which is equal to our divisor, which is 3n minus 4, times our quotient, which is 5n plus 6. So we're going to multiply the divisor and the quotient. So we have 3n times 5n plus 6 minus 4 times 5n plus 6, which is equal to 3n times 5n is equal to 15n squared. Then 3n times 6 is equal to 18n. The negative 4 times 5n is equal to negative 20n. The negative 4 times positive 6 is equal to negative 24. Then we're going to combine the similar terms. So we have 15n squared, positive 18n minus 20n is equal to negative 2n minus 24. Therefore, the product of our divisor and the quotient is 15n squared minus 2n minus 24, which is similar to our dividend 15n squared minus 2n minus 24. Another example, divide 6x cubed minus 3x squared plus 2x plus 3 by x minus 2. So our solution, first divide 6x cubed by x to get the quotient 6x squared. Then the product of multiplying x minus 2 by 6x squared is 6x cubed minus 12x squared. Then we're going to subtract, then divide 9x squared by x to get the quotient 9x. Then we're going to multiply x minus 2 by 9x. So we have 9x squared minus 18x. Then subtract. Then divide 20x by x to obtain the quotient positive 20. Then multiply x minus 2 by 20. So we have 20x minus 40. Then we're going to subtract. So 43 cannot be divided by x. Hence 43 is the remainder. Therefore, the quotient is 6x squared plus 9x plus 20, remainder 43. Or 6x squared plus 9x plus 20 plus 43 over x minus 2.